this episode, we're going to make identity boundaries feel real and testable across cloud environments. Because many cloud breaches grow large not because attackers are brilliant, but because boundaries were assumed instead of validated. When beginners hear about accounts, subscriptions, and projects, they often think those are mainly billing containers or organizational labels. Yet in cloud security, those constructs are meant to create meaningful separation. If identity can move too freely across those boundaries, then a compromise in one area can quietly become access everywhere, which defeats the purpose of having multiple environments at all. The goal here is to help you understand what identity boundaries are supposed to accomplish, how they fail in practice, and how you validate that they actually work under real attacker pressure. By the end, you should be able to read a scenario and tell whether boundaries are genuine security controls or merely names on a diagram. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good place to start is to define what an identity boundary is in plain terms, because the phrase can sound abstract if you have not seen it play out. An identity boundary is a limit on where an identity can be used and what it can affect, especially when that identity crosses organizational containers like accounts, subscriptions, or projects. In cloud, an account-level boundary often aims to separate environments, teams, or business units so that access and impact are contained. If an identity from one boundary can directly administer another boundary, then the separation is weak, even if network segmentation exists. Boundaries should reduce blast radius by ensuring that compromise of one identity or one workload does not automatically grant access to everything else. Validation means checking that the limit is enforced by design and by configuration, not just intended in a policy document. It helps to recognize that cloud providers offer these containers for multiple reasons, and security is only one of them, which is why the default use can be misleading. Accounts, subscriptions, and projects support billing, resource management, and operational organization, but they also provide a natural place to enforce access control and separate governance. Beginners sometimes assume that because resources are in different containers, access is automatically separated, but that is not always true. Access separation depends on how identity is structured, how roles are assigned, and whether there are shared administrative identities that span multiple containers. A common weak pattern is centralizing administration so heavily that every boundary is managed by the same powerful identity, turning boundaries into administrative fiction. Validation requires you to look at who can act across containers and how easily they can do it. One way identity boundaries fail is through shared identities that exist across multiple containers, especially when those identities are used for convenience. If a single administrator account can manage development, testing, and production, then a compromise of that account is a full environment compromise. Even if the account is protected with strong authentication, it still becomes a single point of failure and a single point of attack focus. A similar problem happens when a single workload identity is reused across multiple accounts or projects, meaning one compromised workload can access resources in many places. Reuse happens because it feels efficient to maintain fewer identities, but it increases blast radius dramatically. A strong boundary design prefers separate identities per environment and per purpose, even if the identities are centrally managed, because separation at the identity layer is what makes boundaries meaningful. Another failure mode is broad trust relationships between containers, where one environment is allowed to assume roles or access resources in another environment without strict restrictions. Trust relationships can be a powerful tool for controlled cross-boundary access, such as allowing a central logging account to read logs from many places or allowing a deployment system to push updates into specific targets. The problem is that trust relationships are often configured broadly to avoid deployment friction, and broad trust turns cross-boundary access into an easy escalation path. If a compromised identity in one container can assume a high-privilege role in another container, then boundaries collapse at the moment of compromise. Validation means examining whether trust relationships are narrow, purpose-specific, and constrained by conditions, or whether they are general and permissive. A calm exam-ready approach is to treat cross-boundary trust as a potential ladder and to ask who can climb it and under what circumstances. Validation also includes confirming that administrative scope is limited appropriately, because the highest impact boundary failures usually involve administration. An identity boundary is strongest when administration is segmented, meaning administrators have scope aligned to the environment they manage. In practice, teams often want centralized administration for efficiency, and some centralization can be safe, but only if it is designed with strict role separation and careful controls. For example, central teams might be able to set guardrails without having full access to data, or they might manage policy templates without having day-to-day access to production resources. The weak version of centralization is full control everywhere by default, which means the boundary is meaningless. Validation means identifying what central roles can do, whether they can access sensitive data across boundaries, and whether their permissions are minimized to governance needs. When governance roles are designed well, they strengthen boundaries rather than erase them. Another critical aspect of validating identity boundaries is understanding the difference between authentication boundaries and authorization boundaries. Authentication answers whether an identity is real and verified, but authorization answers what that identity can do and where it can do it. You can have strong authentication across the entire organization and still have weak boundaries if authorization is broad. Beginners sometimes focus on sign-in security and assume that means boundary security, but an attacker with valid credentials can still cross boundaries if the authorization model permits it. This is why least privilege and scoping remain central even when authentication is strong. Validation should therefore include checks on where identities are authorized, not just how they log in. In exam scenarios, look for language that emphasizes strong login protections but also mentions broad roles, because that combination often signals boundary risk. Boundary validation also includes checking for unintended inheritance, where permissions assigned at a high level flow down into many containers without careful control. Many cloud governance models allow roles to be assigned at an organization level or management group level, and those roles can automatically apply to many accounts or projects beneath them. This can be helpful for consistent policy, but it can also be dangerous if a powerful role is assigned too high. A role that was meant to help with a small scope can unintentionally become global, creating accidental admin across the organization. Validation means understanding where roles are assigned and how far their scope extends, not just what the role contains. If an identity is bound at a top level, then it may reach into environments that were supposed to be isolated. A mature boundary design uses high-level assignments carefully and avoids placing broad permissions at levels where they cannot be easily contained. Another beginner misunderstanding is treating network boundaries as a substitute for identity boundaries, which is a common source of quiet exposure. Network segmentation can limit traffic flows, and that is important, but identity can still act across networks because cloud management APIs are often reachable from many places. If an attacker steals an identity token, the attacker can often manage resources through cloud APIs even if network segmentation between workloads is strong. That means identity boundaries are a separate dimension of containment, and they must stand on their own. A secure design aligns network boundaries and identity boundaries, but it does not assume one replaces the other. Validation should therefore consider whether an identity from one environment can administer another environment regardless of network separation. If it can, then a compromise might bypass network boundaries entirely. To validate boundaries, you also need a clear sense of what normal cross-boundary access should look like, because some cross-boundary patterns are legitimate and necessary. Centralized logging is a good example, where a dedicated environment needs read access to logs from many accounts, but not write access and not data access. Centralized security monitoring can also be legitimate, where certain roles need visibility into configurations and events across the organization to detect risk. Deployment systems may need narrowly scoped access to push changes into target environments, but that access should be restricted to deployment functions and specific resources. The goal is not zero cross-boundary access, but controlled cross-boundary access with minimal permissions and clear intent. Validation means ensuring that the only cross-boundary access that exists is the access you can explain, justify, and monitor. If cross-boundary access exists that nobody can explain, you should assume it is a gap. Monitoring and evidence are part of validation because boundaries that cannot be observed are difficult to trust. You want to be able to see when an identity crosses a boundary, such as when a role is assumed in another account or when administrative actions occur in a different subscription. If you cannot see those events, then you may not notice boundary collapse until it is too late. Visibility also supports audits, because you can verify that cross-boundary roles are used only when expected and not used for unrelated actions. A strong design treats cross-boundary assumption and cross-boundary administrative actions as high-signal events worth alerting on. This is not about watching every action constantly, but about making boundary crossing visible enough that unusual patterns stand out. Validation is stronger when it produces evidence that can be reviewed, not just confidence based on intent. It is also important to validate boundaries against real attacker behaviors rather than against ideal assumptions. Attackers who obtain credentials will test scope by listing resources, probing permissions, and attempting role assumption across boundaries. If your boundary design allows them to discover and assume powerful roles across many accounts, you have a boundary failure. If your design limits what they can see and prevents role assumption without strict conditions, the attacker's exploration will be constrained. This is why least privilege within each boundary matters as much as separation between boundaries. A boundary is not truly protective if everything inside it is over-permissioned and easy to enumerate. Validation should therefore consider how much discovery is possible from a compromised identity and whether discovery can be used to jump to other environments. When you evaluate identity boundaries in an exam scenario, you should train yourself to look for a few specific risk signals without turning it into a checklist recitation. Watch for shared administrator identities across environments, because that collapses boundaries quickly. Watch for broad trust that allows role assumption across many containers, because that creates escalation ladders. Watch for high-level role assignments that inherit widely, because that can create accidental admin everywhere. Watch for weak monitoring around cross-boundary actions, because invisible boundary crossing is hard to control. Then look for positive signals, such as separate identities per environment, narrowly scoped cross-boundary roles for specific governance needs, and strong evidence trails for boundary crossing events. If you can weigh those signals calmly, you can decide whether boundaries are validated or merely assumed. As we close, validating identity boundaries across accounts, subscriptions, and projects is about confirming that organizational containers actually reduce blast radius and prevent a compromise from spreading. Boundaries fail when identities are shared broadly, when trust relationships allow easy cross-boundary role assumption, and when permissions inherit widely from top-level assignments. Boundaries are strengthened when identities are separated by environment and purpose, when cross-boundary access is narrowly scoped and justified, and when boundary-crossing actions are visible through monitoring and audit evidence. Network segmentation helps, but it does not replace identity containment, because cloud management access can often bypass network barriers once credentials are stolen. When you can reason about identity boundaries this way, you can spot quiet exposure that hides behind neat diagrams, and you can choose designs and answers that preserve separation even under real attacker pressure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.